Welcome to NYP Live Studio. I'm very sad today because it's going to be the last session since March to today, Science 101. To the live audience out here, stay tuned, we're going to have fun today. And for those at home, don't run away, stay on. So what is the topic today? Eggs. So what comes first, chicken or eggs? No, this is not the topic we're going into. Today we are going into the favorite food of most ladies, cakes. So, what does these two have in common? What does it has to do with Science 101? I think all of you who has done bakery or make cakes before, you have certainly whipped up the egg whites to make cakes. That is nothing new. But how many of you know what goes into it? What makes it happen? Alright, what is the science behind it? That is the whole thing about today. To let you know in the short presentation, and the takeaway is that you're going to remember how does egg white can be made into, we can create egg whites into foams, and these foams can be used to make cakes. Alright, now for that we will move very soon to Veron, our chef, who will be doing the demonstration, and thereafter our research scientist Nick will be explaining to you all the science behind it. Okay, let's go.
Chef Veron in the house.
Hello, I'm Nick and I'll be explaining the science behind egg foams and Veron's secrets to success. Okay, her first success tip, as you have seen just now, is to remove the yolk. This is because egg yolks contain about 30% of fat, and fat is the biggest enemy of egg white foam. Even the slightest amount will block the foaming action, and this is because the fat molecules are hydrophobic, and although they are unable to create a stable structure, they compete with the proteins for alignment around air bubbles in the foam formation process, which will be explained later. The second tip is to add lemon, lime or cream of tartar to help stabilize the foam and prevent over-whipping. The acidic nature helps to denature the proteins quickly to align themselves around the air bubbles and stabilize the foam. They also make it harder for the sulfur or cysteine amino acids in the proteins to lose their hydrogen and form disulfide bridges. This ensures that the air bubble network is not too tightly bonded and therefore help to prevent over-whipping. Another tip is to slowly add sugar at the formation of soft peaks. Sugar stabilizes the foam as they draw water and dissolve, making the protein network around the air bubble rigid and stable. They also increase the viscosity of the water surrounding air bubbles so that they do not get drained and cause over-whipping. However, they should not be added at the start as it will result in difficulty of the proteins to denature and cause smaller air bubbles to be formed, resulting in a finer and denser foam. Now let's take a look at the whisking and foaming process.
Ready, go!
The mastermind behind egg white foam is the egg proteins. These proteins are made of amino acids with this structure: a carbon center bonded to hydrogen, an amine group, a carboxylic group, and an R group. This R group determines the nature of the protein, and one way to classify them will be by their affinity to the water. These red dots represent amino acids with R groups that cause them to hate water. We call them hydrophobic. And the blue dots represents amino acids with R groups that cause them to love water. We call them hydrophilic. For proteins to form, these amino acids, both hydrophobic and hydrophilic, are joined together by peptide bonds in orders specific to the protein, forming the primary structure of the protein. In the native state, the long chains are folded, influenced by the amino acid sequence and the interactions of the R groups, such as hydrogen bonds, hydrophobic interactions, and van der Waals interactions. This results in the secondary, tertiary, and quaternary structure of the proteins, determining their shape. Egg proteins are folded and curled up in spherical shapes, with the hydrophobic parts facing inwards and the hydrophilic parts facing outwards, surrounded by water in the egg white.
Whisking will introduce air bubbles into the egg whites.
The air is incorporated in at a fast speed, and the mechanical agitation uncurls the proteins into long chains. This process is called denaturation. Only the secondary, tertiary, and quaternary structure is affected, as there is not enough energy to break the strong peptide bonds which forms the primary structure of the protein.
Here you can see the bubbles starting to form.
What happens in the formation of bubbles is that the denatured proteins align themselves around the air bubble, with the hydrophobic part moving away from the water to encase the air bubble, and the hydrophilic part staying outside with the water. As the proteins lie on the interface between air bubbles and water, they interact and stabilize the network.
At this stage, the egg whites are near to reaching its peak.
There are several stages of the egg foam. First is the foaming stage just now, where some foams form as the air bubbles are incorporated into egg white. Now, as more air bubbles are incorporated, the protein-coated bubbles are more densely packed. The water from the egg stretches thinner and the foam becomes drier. The peak is where the maximum foam volume is achieved. If whisking is continued, the air bubbles become more tightly packed and end up squeezing water out of the network, resulting in an overwhelmed egg white that separates into liquid and a dry crumbly foam.
The egg white has reached its peak, which we call the ribbon stage.
Amazing. Incredible. Outstanding. Amazing.
So this is the phenomenon of egg whites. Thank you. So welcome back. So guys, ladies, how was the food tasting? Great. Yes, I hope you do remember what you have learned from Nick, the short takeaway. Now, let me see. As usual, I'm going to have some queries from people at home. Alright, okay. Someone is asking me, what is so special about eggs? Can they do with other what? Duck eggs? Never mind, I will try to answer that. Ostrich. And this guy say what? Crocodile eggs. Can we do that with that? Can we do foaming of egg whites from crocodile eggs? Anyway, I know you guys will ask, and come all prepared. Eggs, right? We got from, let me see, these are quail. Alright, the orange one is definitely chicken from hens. This golf ball, I doesn't know what is it. Maybe ostrich. Duck egg cannot be used because of this globulin. Alright, this particular protein is not present in the egg white of duck eggs. Alright, for this is necessary to be. This is one of the protein that is responsible in the hen and the chicken egg whites that make all this foaming possible. So there are actually 4. 1, 2, 3, 4. Alright, these 4 proteins are present in eggs from the chicken. They are responsible to make this thing possible. Alright, the foaming and the unfolding of the proteins. Alright, attraction to the water and the air. I think you heard that from our research scientist Nick just now. Alright, so this will be the last session for this Science 101. We are going to miss you.